Hello, everybody. Today I have a calculus question. Given the derivative of the function, the graph is given. So this is the graph of the derivative. What I want the original function. And I want to sketch it. Sketch the original function y as a function of x. This is a request from a student. There is a condition that when x is 0, the original function y is 0. So, how do I graph the original function? Let's see what kind of information I have here. Remember, this is the derivative. The derivative is 0 here, 0 here, and 0 here. When the derivative is 0, I have either a maximum or a minimum. So I have a maximum, minimum here, maximum, minimum here, and a maximum, minimum here. Look at the derivative. The derivative changes from negative to positive, which means the graph of y is decreasing here and increasing here. So from decreasing to increasing, it is a minimum. So I have a minimum at x equals 1. I start from here. I have a minimum here, so I have something like this. Now the next derivative equals 0 is here. Now the derivative is positive and then negative. So from positive to negative, which means my y, the graph of y is increasing and then decreasing. So at x equals 6, I have increasing, decreasing, which means a maximum. So at here, I have a maximum. All right. At this point, the derivative is 0, so I have a maximum, minimum. Then it is decreasing here and then increasing here. You see, negative derivative goes to positive derivative, so it's decreasing here and increasing here. So this is a minimum. At x equals 8, it is a minimum. At x equals 8, I have a minimum. All right. So I should say, I'm very sorry that I'm doing this under the sunshine, and I have some shadows. It's not too good, but you can still see that. All right, let me continue. Another thing. The derivative is maximum, minimum, maximum, minimum. What does that mean? The derivative is maximum or minimum. When the derivative is maximum or minimum, the second derivative is 0. And remember that when the second derivative is 0, you have a point of inflection. So at x equals 2, 3, 5, 7, you have a point of inflection. Point of inflection 2, 3, 5, 7. So I have point of inflection here 2, 3, 5, 7. So I have a minimum here, so I go here. So concave up. But since at x equals 2 I have a point of inflection, so this is concave up, then I must have a concave down between 2 and 3, concave down. So I must have this kind of thing, right? This is concave down. But this is point of inflection, so I have concave up. Concave up. And then point of inflection here, point of inflection. So between these 2 points of inflection, I have concave down. That's why I have a maximum. So I have a maximum. I have a maximum here, concave down. Okay, so concave up, concave down. And then I have a minimum. So I have a minimum here. So this is the shape of my y. So I erase my rough sketch here. Therefore, let me make this a little darker. So I have a minimum here. I have a minimum here. Concave up. This is concave up, minimum here. Then concave down. This is concave down. And then again concave up. This is concave up. So I have a point of inflection here. Another point of inflection here. And this is another point of inflection. Another point of inflection here. So this is concave down and a maximum here. And a maximum here, okay. And a minimum here. Concave up. Okay. So this is my rough graph of the original function y. So this is the original function, and the given graph is my derivative. Okay? Minimum, maximum, minimum, point of inflection. So that's the answer to this request question. Good. That's it for this lesson. Thank you for watching. Goodbye.